This component is called a transistor. A transistor is essentially an electronic switch, at least how we will use it here. Specifically, we can build our logic gates using NMOS transistors. The transistor has one input which controls if the switch is closed or open, making a circuit connection or breaking the connection respectively across its ends. The NMOS transistor is turned off, or an open switch, when 0 volts is applied to its input. The transistor is turned on, or becomes a closed connection, when there is a high voltage, like 5 volts, applied. Let's create a simple circuit to create a NOT gate. We connect our circuit to a 5-volt power supply, which passes through a resistor R to prevent too much current from going through the circuit, and a transistor, our switch. The other end of the transistor is connected to ground to complete the circuit to allow for current to flow when the switch is closed. If the input to the transistor is 0, or 0 volts, the switch is open, meaning there is no current flowing from our 5-volt power supply to ground. In this case, the output is 5 volts. In other words, a 0 input produced a 1 output. Conversely, when the input is 1 or 5 volts, the switch is closed. This creates a connection to ground, which pulls the output voltage to the ground voltage, which is 0. Thus, an input of 1 makes an output of 0. This is exactly the desired behavior of a NOT gate. How can we create an AND gate using NMOS transistors? An AND gate has 2 inputs, so we use 2 transistors. Our circuit is connected to a 5-volt power supply through a resistor and passing through 2 transistors in series to ground. In this case, the output is going to be 5 volts if either transistor is open, since there won't be a connection to ground. The only time the output voltage is 0 is if both transistors are closed at the same time, or both have inputs of 1. But wait, that's not quite right. According to the AND gate truth table, we should get a value of 1 when both inputs are 1, not 0. It's the opposite of what we want. And this is true. We actually created a negation of an AND gate here called a NAND gate. This is easily fixed. We can cascade the output of the NAND gate with the NOT gate that we created to invert the output value, and the output will be exactly what we want for an AND gate.